Question 27. The diagram shows triangle X drawn on a coordinate grid. This is triangle X and this is a coordinate grid. The A part of it. Draw on the grid triangle Y formed by rotating triangle X 90 degrees clockwise about the center of origin. What we're doing with question A is that we're rotating triangle X 90 degrees clockwise about the center of origin. This is the center of origin, center O. We've done a rotation question before. This is the second one. And this is 90 degrees. The first one was 180. When you have 180 is always a straight line. But when you talk about 90 degrees, it's different. And the terms we need to note here. We have 90 degrees, we have clockwise, we have about the center of origin. The center of origin is where X is 0, Y is 0, which is here. I know we're rotating this triangle X about it. So note that this is where we have it. Also the term clockwise. Clockwise is going this way, anti-clockwise is going that way. That will be explained as we move on in the question. We start by naming all the vertex points. This, and this. We can name this X1, X2, X3. Let's say we're rotating this X 180 degrees about the center of origin, which is here. Then from each of the vertex points, you draw a line from them through the center of origin to the end of the grid. But if it's 90, you draw a line to the point of rotation, then make a 90 of that line. So you're making a 90 degrees to this side. If it were 90 degrees anti-clockwise, you make it 90 degrees to this side before you can get the corresponding point on triangle Y. So note the difference between 90 degrees and 180. 180, when it comes to lines and angles, 180 is a straight line. But when it comes to 90, when you have this line and it's clockwise, you draw a line perpendicular to that line that forms an L shape. Just know you're forming an L shape. And you have two major tools to do this. You can either use your protractor or one of the pair of your set squares. But you should know that using a set square is better than using a protractor and making a line that is 90 degrees to the initial line. So if you don't know how to use it before now, you can learn it. So let's go on to solving the question. Let's say you have your 4 cardinal points. 90 degrees clockwise means going this way. When you have your clock, this is like 12, this is like 3, you have 1, 2. If you go this way, you're going clockwise. If you go this way, you're going anti-clockwise. You should note that first. So you should note what it means to go clockwise and anti-clockwise. We've talked about clockwise. Then 90 degrees means you're having like an L shape. This is 90 degrees. You should note that also. We now go to the third point, which is the center of origin. We are rotating triangle X about the center of origin. The center of origin is where we have X to be 0 and Y to be 0. And this is it. This is center of origin. So we are rotating triangle X about this point. And like done with previous questions on that translation, we can name all the vertex points of this triangle. We can name this X1, we'll name this X2, we'll name this X3. Next is to take each of the points, that's the vertex points that we've labeled X1, X2, X3, and with our ruler, we'll draw a line through the center of origin, that's the point of rotation. So we'll take our ruler and we'll do that. We'll start with X1. We'll draw the line from X1 through the center of origin. Just a bit past it. The question says it's rotated 90 degrees clockwise. So we have to get a perpendicular line to this line. That's a line that makes 90 degrees to this green line about the center of origin, which is also the center of rotation. Making it 90 degrees can be done using your set square or your protractor, whichever you prefer. But I think using the set square is easier. You just need to understand that this line to this line of your set square makes 90 degrees. So you have to just place it here in a way that this side sits on the line about the center of origin, which is also the center of rotation. Let's do it so you can understand what is being said. So we're making this part of it sit on this line, and then we'll take the next step. You can see we have it on the line, and this is a 90 degrees. So when you have this on this line, a line that you draw from here, that's the center of origin, which is the point of rotation in this case, makes a 90 to this green line. So we'll draw it. This forms a 90 degrees. So if you are rotating in 90 degrees and you are rotating it clockwise, it has to be in this direction. This is clockwise. So your set square should sit like this. If it were anti-clockwise, it has to sit on the other side. But here it's clockwise, and you have to make the 90 about the center of origin. Sometimes, if you're very good, you don't even need to draw the initial green line past the point of rotation. But in this case, you can do it. Draw the line long enough, a bit longer than this length. Now you have a line that is 90 degrees to the initial line you drew. Next, what you do is to measure the distance between x1 and the center of origin, which is the point of rotation. It's the same distance as the center of origin and corresponding vertex point on triangle Y. So we'll take our ruler and measure the distance between the center of origin or the center of rotation and x1. If you look closely at the reading, this is 0 at the center of origin. To x1 you have it at, this is 2.5, this is 2.6, this is 2.7, and it's a bit past 2.7, it's like 2.75, but 2.7 is good enough to get the location of y1, which is the corresponding point of x1 on triangle Y. So we come to the line which is at 90 and measure 2.7. Now this is 0, we have 2.7 here, and the closest point on the grid where a vertical line meets with an horizontal line is right here. So we mark the point. This point is y1. We have y1, we created it from x1. Take off the green lines so we can have a neat work. So we erase both lines. Let's go for x2. The point of rotation is at the center of origin, so it's right here, and we'll draw a line from x2 to the center of origin. Then we'll draw another line which is 90 degrees to the line that runs from the point of rotation. To draw this kind of line, you won't put too much pressure on your pencil. You just make it light so you can erase it easily. So let's draw the line. We've drawn a line from x2 to the center of origin. Next, we take our set square and sit this part on this line to make sure this part makes a 90 degrees to this green line. You have to note how to sit this right. You make sure that this part of it is on the point of rotation. Next, you draw a line that is 90 degrees to the initial green line. Draw it as long as possible. Now that you have the line, you can take off your set square. Next, you measure the distance between x2 and the center of rotation, which is the center of origin in this case. To know the distance between the center of origin and y2, so we measure the distance between the point of rotation and x2. This is x2 at 0. We have the center of rotation at 5.3. So the distance between x2 and the center of rotation is 5.3. That should be the same distance between the center of rotation and y2, which is corresponding to x2 on triangle Y. So we place the 0 point of our ruler at the center of rotation and trace it down to where we have 5.3. This is 5. 5.3 is here. You have to get the exact point where a vertical line of the grid meets with an horizontal line, which is this point. That at x is 3, y is minus 3. Take our ruler off and mark the point. This is y2. We've marked y2. With this, you can take off the green lines. We have point y2. We now need y3. As done with x1, x2, we also do with x3. From point x3, you draw a straight line to the center of origin, which is the point of rotation. We have it here. You don't even need to draw the line. You have a straight line already that runs from x3 to the center of rotation. And here you can use the grid to solve this problem. You don't even need your ruler to measure. This is like 0. You have 1, 2, 3, 4. It's 4 away. If you make a line 90 degrees to this line, it's coming like this. This line of the x-axis is 90 degrees to the line of the y-axis. So you don't need your set square or your protractor in this case. You just follow this line for the initial line that runs from x3 to the center of origin. Then this makes a 90 to that line. You can use your ruler to measure, but since you have your grid lines, you don't need your ruler. From here you count 1, 2, 3, 4. It's 4 grid lines away. So from here you count 1, 2, 3, 4. This is also 4 grid lines away. If you use your ruler to measure the distance between x3 and the center of rotation, and also the distance between the point of rotation and this point here, they will actually measure the same, which is 4 grid lines away from it. So you mark this point as your y3. So with the 3 label points on triangle X, we've been able to get the 3 corresponding points on triangle Y. We now join the points to make triangle Y. Let's join y1 and y2 first. Then we join y2 and y3. Then y3 and y1 to make triangle Y. We now have triangle Y, which is a 90 degrees clockwise rotation of triangle X about the center of origin, which is point X is 0, Y is 0. Hope you understand.